In this episode of complex number, we are going to talk about the different ways of representing a complex number, such as a complex number can be represented in Cartesian form, in polar form, and in exponential form. From episode 1 to episode 5, we have seen a complex number can be written in form of z equals to a plus bi, where a and b are real numbers. Bi is the imaginary part of complex number. This way of writing a complex number is called Cartesian form. It is also called as rectangular form of the complex number. A Cartesian form of complex number z equals to a plus bi can be represented in Argand's diagram as shown in the figure. When we represent this complex number in Argand's diagram, we draw a projection on real axis and complete the triangle OAP, where theta is the argument of complex number and r equals to modulus of complex number. From this figure, we obtain sin theta equals to b upon r implies b equals to r sin theta, and cos theta equals to a upon r implies a equals to r cos theta. Here r equals to under root of a square plus b square and z equals to a plus ib. We are already having a equals to r cos theta and b equals to r sin theta. Call it as a 1 and call it as a 2. Now putting 1 and 2 in equation z equals to a plus ib. That is, let us call it as a equation 3. So put 1 and 2 in 3. So we get z equals to r cos theta plus I r sin theta. From this we can take r common. So we get r cos theta. R is common. So we get cos theta plus I sin theta inside the bracket. This way of writing the complex number is called polar form. So this is required polar form of complex number. This is not the general form. The general form of complex number in polar form is given by r and cos 2k pi plus theta plus I sin 2k pi plus theta. So this can be the general form of polar form of the complex number. That means this is general polar form of the complex number. And k equals to 0, 1, 2, 3, etc. Suppose z equals to a plus ib, then its polar form is given by z equals to r cos theta plus I sin theta, where cos theta plus I sin theta equals to e raised to I theta. This is nothing but called Euler's identity. Therefore, Z equals to that. This was the polar form of the complex number. So, the polar form of the complex number in short can be written as r into e raised to I theta, or in general, the general form can be written as r into e raised to I and 2k pi plus theta. This way of writing the given complex number by using e raised to I theta or e raised to I into 2k pi plus theta is nothing but called exponential form of complex number. Now we'll take some examples for understanding polar form and exponential form of a complex number. Convert to polar form and exponential form. So we are having Z equals to 3 plus 3 root 3I comparing with A plus BI implies A equals to 3 and B equals to 3 root 3. A is greater than 0, B is greater than 0 implies Z lies in first quadrant. So we can draw the rough diagram for orthographic plane. This is what the given complex number, and the points are 3, 3 root 3. We need to find out theta. Theta nothing but argument. So theta equals to tan inverse of B upon A. So theta equals to tan inverse of 3 root 3 upon 3. 3 get cancelled. Theta equals to tan inverse of root 3 equals to pi by 3 radians. Step 1 is over. This was the step 1. Now step 2. In step 2, we find out the modulus of given complex number, that is modulus of Z equals to R equals to under root of A square plus B square, that is equals to under root of 3 square plus 3 root 3 whole square equals to 9 plus 9 into 3 under root of 9 plus 27 equals to under root of 36 equals to 6. We consider only positive value, therefore R equals to 6. Now step 3. Polar form of Z. Polar form is given by polar form of Z equals to R cos theta plus I sin theta. R value is 6 and theta value pi by 3. So cos pi by 3 plus I sin pi by 3. And the general polar form of the given complex number can be obtained by adding 2k pi plus pi by 3 plus I sin 2k pi plus pi by 3, and the exponential form of this polar form is quite easy. Exponential form equals to 6 will remain as it is, e raised to I will come here, and in place of theta 2k pi plus pi by 3 will come. So this is the exponential form of z equals to 6 into e raised to I 2k pi plus pi by 3. In this way, we can find out the polar form and exponential form of a given complex number. So in this episode, we have understood how to convert a given Cartesian form of complex number into polar form and exponential form. In next video, I shall be talking about de Moivre's theorem. Please give me your feedback regarding my presentation and my quality of my videos. If you like my presentation, if you want to learn the mathematical skills, you can subscribe my channel because I keep on producing the videos related to mathematics. Meet you again with another video, de Moivre's theorem. Till then, wish you good luck. All the best.